In this video, we're going to take a look at logarithms and logarithmic functions. Now, sometimes you might have 2 to the power equals 8, and you need to figure out what that power is. So 2 to what power equals 8? Well, most of you are going to say 3 or 2 cubed. And so yes, that exponent is 8. Or you might be thinking, 6 to what power is 36? Most of you are going to realize that that power has to be 2. And so when it's a nice number over here that is 2, or this base to some power equals this, it's very easy. But consider 7 to some power equals 54. Well, you know 7 to the first is 7. 7 squared is 49. So if the exponent was 2, we're not quite there yet. But 7 cubed is way too big. So you'd at least know your answer is between 2 and 3 for that exponent. But it still doesn't really help you figure that out. Now, you could start using trial and error and narrowing it in. However, we could use a new mathematical function called a logarithm to help us out. A logarithm is really an exponent. It allows you to be able to solve that for your exponent. So if we take 7 to some unknown power equals 54, if we use a logarithm, we'd write log base 7 of 54 equals our unknown question marker, which is our exponent. Now remember, any logarithm is just representing the exponent that you're looking for. That's going to be a key thing for you to remember. A logarithm is just representing an exponent that you're looking for. So this was a logarithm here, log base 7 to 54, and that told us our exponent for the problem that we had over here. Now, in general, the definition of a logarithm is given to you right here. If you have x equaling b to the a, with b being your ace, or your base, and a being your exponent, this is the exponential form. It's identical in meaning to your logarithmic form over here, which is log base b, the same b that we had over here, of x equals a, which is was your exponent. Now, this is not b to the x, it's log base b, so that's a subscript, and x is just written normal. Now, over here, remember when we were looking at exponential functions, whatever your exponent was on had to be positive and couldn't be equal to 1. And so that's why we're saying b has to be greater than 0 and can't be equal to 1. Also, if you take any positive number and raise it to a power, you're always going to be getting out positive answers. There's no way for you to get a negative answer. So x is positive. So here, x is positive. So write this down that basically whatever's after your logarithm has to be positive. If you get a negative either in your base or your normal spot here where the x is after a logarithm, it doesn't work. So down here, we have this in logarithmic form, and I want you to use your definition of a logarithm up here and write it in exponential form. For the most part, you could use that formal definition, or you could think Tarzan. We're going to take our base of 8, and why aren't we working here? Here we go, we're a base of 8, and we're going to swing it over. It's going to hit the 2 up as your exponent. So we're going to take our base, swing it over, hits the 2 up as the exponent, and it's going to be equal to 64. Same idea in the next one. We're going to take our base of 16, swing it over, hits the 1/2 up as the exponent. So we're going to have 16 to the 1/2 equals 4. Now, remember, over here on the left, that 8 squared really is 64. A second way to write it is what we had up here with logarithms. And then also 16 to the 1/2. Remember 1/2 is the square root, and the square root of 16 is 4. Just a different way to write it. As we look over here, we're going to do the same thing. We're going to take our base of q, swing it over, hits the t up as the exponent. And the same on this last one over here. We're going to take this whole base, swing it over, hits the st up as the exponent. So that st becomes the exponent for the whole base, so we got to put that whole base in parentheses, equals to what was after the logarithm. Now, instead of using Tarzan, you could have used the formal definition up here, and you would have still got the same answers. You're going to have that formal definition up here and Tarzan memorized. So now we have exponential ones, and we need to go ahead and write it in logarithmic form. The 27 here is your base because that's what your exponent's on. So when you write it in logarithmic form, you're going to go log of your base, and that goes as a subscript. Put the exponent in the other side all by itself, so the 1/3 goes on the other side of the equal sign. What was on the one side by itself goes after your logarithm. So we'd read this as log base 27 of 3 equals 1/3. Same idea with this one. We'll go log of our base of 10. What was on one side by itself goes after that. What was the exponent goes on the other side all by itself. So our 2's the exponent equal to our logarithm. And remember we had said earlier, a logarithm just represents your exponent. So we'd read this as log base 10 of 100 equals 2. This one here would be log base x of 12 equals a. This one here, our base is what's in parentheses, the a plus b. So we're going to have to go log a plus b. We don't necessarily have to put a plus b in parentheses because they're written as subscripts, so it's assumed to be grouped together. Take our exponent of the 7x, put it on the other side, and the 84x plus y goes after our log. And that does have to be in parentheses so that our log applies to the whole thing. Without the parentheses, it would only apply to the 84x. So let's go ahead and evaluate these without a calculator. So this is where you want to think about, what does this mean? It really means 10 to what power equals 1,000. Well, 10 to what power is 1,000? Most of you will know that that is 3. Over here, this means your base of 2 to what power equals 8. So 2 to what power is 8? And that is also 3. When we look down farther here, we're going to do the same thing. We're going to take our base of 9. So 9 to what power equals 3? Well, 9 to what power equals 3? Most of you remember that the square root of 9 is 3. And the square root's really the 1/2 power. So we just get 1/2. Because 9 to the what power is 3? 9 to the 1/2 is 3. This one here means 8 to what power is -5. But wait a second. 8 to any power is never negative. You can also remember that whatever is after your log has to be positive according to the definition. So this is no solution. Over here, this is 8 to what power equals 1? Well, 8 to what power is 1? Remember, anything to the 0 power is 1, so our answer is 0.